You've probably heard a ton about AI that can write code, right? But what if AI could also be our digital bodyguard? What if it could find those sneaky, hidden security flaws in the software we all use every single day and then actually fix them all by itself? Well, today we're diving into a pretty wild new AI from Google called CodeMender that does exactly that.
So, for a little while now, AI has been an incredible bloodhound for security experts. These tools can scan millions, literally millions of lines of code, sniffing out what are called zero-day vulnerabilities, the really nasty flaws that even the best human developers might miss. And yeah, that's a huge deal. But it's also created this weird new problem, a new bottleneck. But what if the AI didn't just dump a massive report on your desk and say, good luck? That is the giant leap CodeMender takes. It doesn't just find the bug, it goes deeper. It figures out the real root of the problem. It writes the code to fix it, it tests its own solution like crazy, and only then does it serve up a polished, ready-to-go patch for a human to review. I mean, it's the whole shebang, automated from start to finish.
And look, this is not just some experiment locked away in a lab. In just the last 6 months, CodeMender has already successfully submitted 72 security patches to major open source projects. We're talking about insanely complex software, one with over 4.5 million lines of code. This AI is out there in the wild right now, quietly making all the stuff we rely on every day that much safer. So why do they even need to build something this powerful? To really get why CodeMender is such a big deal, you gotta understand this growing crisis in software security. Let's call it the vulnerability overload. Okay, so here's the fundamental problem. Our AI tools, like Google's own OSS Fuzz, have gotten way too good at finding vulnerabilities. And our human developers? Well, they just can't keep up with the sheer number of bugs being found. It's creating this incredibly dangerous bottleneck, where we're finding risks way, way faster than we can patch them. CodeMender was built specifically to break that bottleneck.
All right, so how does this thing actually work? How does it go from spotting a problem to delivering a perfect fix? Let's get into the nitty-gritty.
So what's CodeMender's secret sauce? Well, it really comes down to three things. For starters, it can be both reactive and proactive, and we'll dig into what that means in a second. Then it's powered by Google's latest Gemini models, which gives it some serious brain power to reason through super complex code. And maybe most importantly, its self-checking process is just incredibly tough. It will not submit a fix unless it is absolutely sure it's a high-quality patch that works and won't break anything else. The way it works is actually pretty brilliant. It starts by digging way past the obvious symptoms to find the real, true root cause of a bug. Once it's got that figured out, it generates a potential fix. But it doesn't just stop there. No way. It then validates its own work, making sure the patch is correct and doesn't cause any new problems. Only after it passes all of its own internal checks does it get submitted for a final human sign-off. And get this, it's not just one giant AI brain doing all the work. It's actually better to think of CodeMender as a super specialized little team of AI agents working together. You've got the diagnoser, who's like the detective figuring out what went wrong. Then there's the patch writer, the engineer who actually codes the fix. Next up, the critic acts like a senior developer, double-checking the patch for any hidden problems. And finally, the validator runs a whole suite of tests to make sure the fix actually works and the whole system is stable. Let me give you a real-world example of this deep thinking. So a crash report came in pointing to something called a buffer overflow, a super common bug. Now, most tools would just flag the line of code where the program crashed and call it a day. But CodeMender, it went deeper. It traced the problem all the way back to a tiny, subtle error in how the program was handling XML files in a completely different part of the code. That's not just matching patterns, that is real, actual problem solving. And all of that leads us to maybe the coolest part about CodeMender, its ability to be both reactive and proactive. It's not just about fixing today's problems, it's about preventing tomorrow's before they even happen. Let's break this down. So reactive security is what we're all used to. It's the fire drill, right? A bug is found, and everyone scrambles to patch it. It's a constant game of whack-a-mole. Proactive security, on the other hand, is the holy grail. That's where you systematically rewrite the code to wipe out an entire class of potential bugs before an attacker could ever use them. The libweb library, and that's a piece of code used on millions of devices to handle images, is a perfect example. A critical bug was found and was actually being used by attackers in the wild. So after the emergency patch was out,
CodeMender was put on the case. And it didn't just fix that one specific bug. It went through and proactively hardened the entire library to prevent any similar kinds of attacks from ever happening again. And this, right here, is the key. By proactively rewriting and strengthening the code, CodeMender didn't just swat one fly. It made an entire category of future exploits totally impossible. This is a huge shift from just playing defense to actually rebuilding the foundation to be stronger than ever.
So if we zoom out for a second, what does something like CodeMender really signal? It's a perfect example of a major shift happening in AI right now, the move away from AI tools and toward AI agents. So what's the difference? Well, think of an AI tool like a calculator or a spell checker. It's passive. It just sits there and waits for you to tell it what to do. An AI agent, on the other hand, is autonomous. You don't give it a command, you give it a goal, like secure this entire code base, and it figures out the steps, makes decisions, and solves problems all on its own to get there. So why does any of this matter to you? Well, for businesses, this means you can have security that scales, constantly watching over and fixing your code. For developers, this is a lifesaver. It means less time spent on soul-crushing bug hunts and more time actually building cool new things. And for the whole open source community, it means the critical software we all depend on can be made safer for everyone, even if the projects don't have a giant security team. And that really leaves us with a huge kind of mind-blowing question. We're seeing AI agents move beyond just helping us out to taking on these massive, complex jobs like securing our entire digital world. As these agents get smarter and more capable, you have to ask, what other complex, goal-oriented tasks that we always thought were uniquely human could be next?